The year was 1941, and dark storm clouds of war hung heavily over the vast expanse of the Pacific Ocean. The sudden and devastating surprise attack on Pearl Harbor thrust the United States into the Second World War, throwing its forces into a theater where the weather, the ocean, and the enemy were equally unforgiving. The Imperial Japanese Air Force had established absolute air superiority over the skies of the Pacific. Their most potent and feared weapon was the Mitsubishi A6M Zero, a fighter plane so fast, agile, and maneuverable that it completely outmatched any American aircraft in service at the time. Facing a Zero in aerial combat was practically a death sentence for American pilots. Existing American fighters like the Curtiss P-40 Warhawk and the Brewster Buffalo were utterly incapable of matching the Zero's tight turning radius and rapid rate of climb. Japan dominated the Pacific skies, and the Allied forces desperately needed a reliable, high-speed weapon, not just to win dogfights, but to fundamentally rewrite the rules of aerial combat. They needed an aircraft capable of flying over thousands of miles of open ocean, destroying the enemy's finest fighters from a distance, and bringing its pilot home safely. The answer to this monumental historic challenge lay in the hands of a legendary engineer at Lockheed Corporation named Clarence Kelly Johnson. That answer was the Lockheed P-38 Lightning. The P-38 Lightning was no ordinary fighter aircraft. It was a masterpiece of aviation engineering that left contemporaries in absolute awe. When the U.S. Army Air Corps issued a requirement in 1937 for a high-altitude interceptor capable of reaching 360 miles per hour, climbing to 20,000 feet, and engaging the enemy at full throttle for at least 6 minutes, most aviation companies declared the specifications impossible. At the time, achieving such speeds and altitudes with a single engine was practically unachievable. However, Kelly Johnson broke completely with convention and designed an aircraft unlike anything the world had ever seen. Instead of one engine, he selected two powerful Allison V1710 engines. But the real magic lay in the General Electric turbo-superchargers integrated into the engines. Utilizing exhaust gases, these superchargers forced oxygen into the engines, even in thin, high-altitude air, allowing the P-38 to maintain its full power and speed at altitudes where other aircraft would stall and sputter. The design of the P-38 was so radical that it was instantly recognizable. It featured a twin-boom configuration where two separate fuselages housed the engines and extended back to support the tail assembly, while the pilot sat in a central cockpit. This twin-boom architecture gave the P-38 not only a striking and intimidating appearance, but also a structural durability that single-engine fighters simply could not match. Crucially, the two propellers rotated in opposite directions, effectively neutralizing engine torque. This meant that the pilot did not have to constantly fight the aircraft's natural urge to roll due to engine torque, resulting in an exceptionally stable gun platform. Yet the P-38's true lethal brilliance was not merely its speed or its twin engines, but the devastating firepower concentrated in its nose that brought absolute ruin to the enemy. Typically, fighter planes of that era carried their machine guns mounted inside the wings. Wing-mounted guns suffered from an inherent drawback known as the convergence point. where the streams of bullets met at a specific preset distance. If an enemy aircraft was closer or farther than that exact range, much of the firepower was wasted. However, because the P-38's engines were mounted in the booms, there was no propeller in the central nose. Taking full advantage of this design freedom, Kelly Johnson packed one 20mm Hispano cannon and 4.50 caliber Browning M2 heavy machine guns directly into the very tip of the aircraft's nose. These weapons fired straight ahead, parallel to one another. Consequently, the stream of bullets and explosive shells shot out like a concentrated laser beam without any convergence distance issues. From 100 yards out to a full 1,000 yards, wherever the P-38 sight was pointed, a wall of metal and high explosives followed, tearing enemy aircraft to pieces in midair. When the XP-38 prototype took its maiden flight in 1939, it sent shockwaves through the aviation world. It shattered records by flying from California to New York in just 7 hours and 2 minutes. But the path for this new masterpiece was far from smooth. The early days of the P-38 were plagued with formidable challenges. It was a complex machine that demanded far more skill and discipline from a pilot. At sub-zero temperatures and extreme altitudes, cockpit heating failures and turbo supercharger freezing caused immense physical hardship for pilots. The most dangerous issue encountered during high-speed test flights was compressibility. When the P-38 entered a steep, vertical high-speed dive, its speed approached Mach 0.65. At these near-sonic speeds, airflow over the wings created shockwaves that locked the elevator controls, tucking the nose downward and pulling the plane into an unrecoverable dive. Several early test pilots lost their lives in tragic crashes before engineers developed specialized underwing dive flaps that restored control and allowed pilots to pull out safely. When the P-38 was initially deployed to the European theater, it faced harsh winter conditions, dense cloud cover, and initial fuel distribution issues that limited its effectiveness high above Western Europe against nimble German Luftwaffe fighters like the Focke-Wulf FW-190 and Messerschmitt Bf-19. However, when this twin-engined monster was deployed to the Pacific theater, it completely turned the tide of the war. The geography of the Pacific was fundamentally different from Europe. Here, there was no solid ground below, only thousands of miles of unforgiving, endless ocean. Operating a single-engine fighter over these vast oceanic reaches was an immense hazard. If a single engine failed or took hit from enemy fire, the pilot faced almost certain death in the ocean or capture in hostile territory. The P-38's dual engines gave American pilots unprecedented confidence. If one engine was destroyed or disabled, the P-38 could feather the dead propeller and limp home hundreds of miles back to base on the remaining engine in the Pacific. American pilots quickly realized that trying to engage the Japanese Zero in a traditional, tight-turning dogfight was suicidal. The Zero was so lightweight and nimble that it could easily outturn a P-38 in a horizontal turning contest. If a P-38 pilot attempted to turn with a Zero, the Japanese fighter would maneuver behind them and shoot them down. P-38 pilots learned that their ultimate advantages were speed, devastating nose-mounted firepower, and incredible diving and climbing capability. They developed a lethal tactic known as boom man zoom, Flying at extreme altitudes, P-38 pilots would stalk the skies from above. Upon spotting Japanese aircraft, the P-38s would dive down at terrifying speeds, unleash a deadly burst from their centralized nose guns, and then, without slowing down to turn, zoom back up into the high-altitude clouds. The Zero lacked the engine power and climb rate to chase a rising P-38, reaching high altitude once more. The P-38 pilots would reset and prepare for their next pass. This strategy left Japanese pilots helpless, with no effective countermeasure against the boom and zoom technique. The arrival of the P-38 Lightning in the Pacific radically reshaped the strategic balance of power. Its exceptional range unlocked operational possibilities that had previously been unthinkable. Equipped with external drop tanks, the P-38 could achieve an incredible combat radius of up to 2,200 miles. This long range made the P-38 the premier escort fighter for heavy bombers. B-17 Flying Fortresses and B-2 for Liberators no longer had to fly deep into enemy territory unescorted. They now had P-38s riding shotgun, sweeping enemy interceptors from the sky before they could close in on the bomber formations. When Japanese pilots first encountered this twin-tailed aircraft in combat, a profound dread took hold of them. They gave the fighter a nickname that became immortalized in military history, Der Gabelschwanzteufel, or the fork-tailed devil, to them. This two-tailed demon appeared out of nowhere, unleashed overwhelming destruction, and vanished back into the clouds before anyone could react. The aircraft not only revived American morale across the Pacific, but proved that the future of air war belonged to speed, power, and superior engineering era ruled by the Lockheed P-38 Lightning. The P-38 Lightning's dominance over the Pacific skies was now firmly established, but its true legacy was carved out by the legendary pilots who mastered its twin engines and forged it into one of the most effective fighter aircraft in military history. America's top two flying aces of World War II, Major Richard Ira Bong and Major Thomas McGuire, both flew the P-38 Lightning to achieve their incredible victory tallies. Major Richard Bong, who became America's highest-scoring ace of aces with 40 confirmed aerial victories, was an outspoken advocate for the aircraft. He frequently asserted that no fighter plane in the world was as reliable, fast, or deadly as the P-38. Bong capitalized on the incredible precision of the P-38's nose cannons, closing in on enemy targets before firing brief, devastating bursts that reduced enemy planes to burning wreckage. Major Thomas McGuire achieved 38 aerial victories, also entirely while flying the Lightning. The synergy between this formidable aircraft and these elite aviators shattered the morale of the Imperial Japanese Army and Navy Air Services. Yet, the most famous, audacious, and strategically important mission in the history of the P-38 Lightning took place on April 18, 1943. This high-stakes operation was codenamed Operation Vengeance. American naval intelligence had broken top-secret Japanese military codes and intercepted a transmission detailing the exact itinerary of Admiral Isoroku Yamamoto, the Commander-in-Chief of the Imperial Japanese Navy and the mastermind behind the Pearl Harbor attack. Yamamoto was scheduled to conduct an inspection tour of air bases near Bougainville Island, His flight schedule was detailed down to the exact minute. The American High Command recognized that eliminating Yamamoto would deal a crushing psychological blow to the Japanese war effort. However, the mission presented an almost impossible tactical challenge. Yamamoto's flight route was nearly 400 miles away from the nearest Allied airbase at Guadalcanal. To complete the intercept, the strike team would need to execute a round-trip flight of over 1,000 miles, flying deep into hostile territory without alerting enemy radar installations. No standard Allied fighter in the Pacific possessed the range and firepower required to execute such a long distance, except the Lockheed P-38 Lightning for Operation Vengeance. 16 P-38 Lightnings were fitted with specialized, extra-large, 310-gallon drop tanks. The flight plan was extraordinarily dangerous. To avoid Japanese radar detection, the pilots had to fly at treetop level, skimming just 30 to 50 feet above the ocean waves. They were forced to maintain strict radio silence for over 2 hours, navigating across featureless ocean entirely by compass headings and dead reckoning. A single navigational miscalculation or timing error would sink the entire mission and leave the fighters to run out of fuel over the ocean. Led by flight leader John Mitchell, the 16 P-38s took off from Henderson Field, Guadalcanal. They skimmed low over the water for hundreds of miles. Through astonishing navigational precision, the P-38s arrived at the exact interception point, precisely as Yamamoto's Mitsubishi G4M Betty bomber and its escorting Zero fighters were descending toward the airfield. The P-38 flight immediately zoomed up into attack formation. The designated attack section, including pilots Thomas Lanphier and Rex Barber, dove directly toward Yamamoto's bomber. Japanese Zeros scrambled to defend their commander, but the high speed and surprise of the P-38 attack gave them no time to react effectively. Rex Barber and Lanphier closed in, pouring 20mm cannon fire and heavy machine gun rounds into the bomber's fuselage and engines. Yamamoto's transport plane caught fire, broke apart, and crashed into the dense jungle below. The death of Admiral Yamamoto was a catastrophic blow from which Japanese military leadership never truly recovered. It stands as the longest successful air interception mission in the history of aerial warfare, executed flawlessly because of the extreme range, speed, and heavy nose firepower of the P-38 Lightning operation. Vengeance proved that the P-38 was not merely an exceptional dogfighter, but a decisive strategic weapon. Following this success, the presence of the Lightning across the Pacific grew exponentially. The aircraft was adapted for a multitude of specialized roles. The F-4 and F-5 variants were developed stripped of all armament and fitted with high-resolution cameras for long-range, high-speed photo reconnaissance, flying at extreme altitudes and speeds. These reconnaissance Lightnings were virtually immune to interception by enemy radar and fighters. They captured thousands of vital aerial photographs of Japanese island fortifications, shipping lanes, and airfields, providing the critical intelligence required to plan the Allied island hopping campaign across the Pacific. Furthermore, the P-38 was modified to serve as a dive bomber, night fighter, and ground attack aircraft, capable of carrying rockets and up to 2,000-pound bombs beneath its wings. It repeatedly obliterated enemy bunkers, bridges, and supply lines. Perhaps the greatest victory achieved by the P-38 Lightning was its systematic attrition of Japan's elite, veteran fighter pilots. Japanese aviators, who had once ruled the skies, found their experience neutralized by the P-38's high-altitude, boom and zoom tactics, and lethal concentrated firepower. Japan lacked both the industrial capacity to build advanced fighters, capable of matching the P-38, and the time needed to train replacement pilots to the standards of those who had fallen. By 1944 and 1945, the Allied forces held absolute air dominance over the Pacific. As American forces liberated the Philippines and pressed closer to the Japanese home islands, the P-38 Lightning remained at the tip of the spear. The roaring twin engines of the Lightning became a symbol of terror for enemy forces on the ground and a sign of absolute protection for Allied troops. When historians evaluated the air war in the Pacific following the surrender of Japan, the P-38 Lightning was recognized as the most decisive and game-changing American fighter aircraft of the Pacific War. It had destroyed more Japanese aircraft than any other U.S. fighter in the theater. The Lockheed P-38 Lightning proved that with cutting-edge engineering, radical innovation, and adaptive tactical doctrine, the fundamental rules of the sky could be permanently rewritten. Kelly Johnson's twin-engine creation not only altered the trajectory of World War II, but laid the structural and tactical foundations for modern multi-role military aircraft. Today, whenever aviation history remembers the golden age of piston-engine fighters, the Lockheed P-38 Lightning stands as a legendary aircraft, a fork-tailed devil that dictated its own rules over the Pacific skies and brought victory to the forces of freedom.